In this video, we're going to examine the primary trigonometric ratios, which are sine, cosine, and tangent. These trigonometric ratios give the ratio of the various sides of a right-angled triangle. Let's take a look at example 1. Solve the following right-angled triangle, ABC, using trigonometric ratios. Round to one decimal place. Recall, to solve a triangle means to determine the lengths of all sides and angles. So we are going to find all the lengths of all the sides and all the angles in this triangle. The first thing that can be done very easily is finding angle C, and that's using the property of the sum of the interior angles of a triangle. And so 180 degrees minus the 90 degrees minus 18.6 degrees results in angle C being 71.4 degrees. So we now have this angle right here. So what we have to do now is we have to find side A and side C. I'm going to use the sine ratio here because sine of 18.6 is opposite over hypotenuse, as we see defined up here. So sine of 18.6 degrees is equal to the length of the opposite side, A, over the length of the hypotenuse, 11.3. Multiplying both sides by 11.3, I have 11.3 times sine 18.6 is equal to A. And so all I did there is I just multiplied both sides here by 11.3. which cancels out over here. And so I can say, therefore, A is approximately equal to 3.6 centimeters. If I wanted to find side C, C is adjacent to 18.6, so I'm going to use the cosine ratio here, adjacent over hypotenuse. So, same thing. Cosine 18.6 degrees is equal to C over 11.3. Multiplying both sides by 11.3, I end up with 11.3 times cos 18.6 degrees is equal to C, and therefore C is approximately equal to 10.7 centimeters. Please note, since I've rounded, I have to put in the approximate sign over the equal sign. In this next example, I'm only given two sides right here, D and F, and I need to solve for the entire triangle. So I'm going to use the tangent ratio. As you can see up here, tangent is opposite over adjacent for angle D right here. So I will then put tangent of angle D is equal to opposite. Okay, so I'm looking at the opposite to angle D, which is 7.4, over adjacent, which is 6.5. If I want to isolate for D, I have to remove the operation of tan. And undoing the operation of tan requires me to use the inverse tan ratio. And so the inverse tan ratio undoes the operations of tan, and we write it like this: tan to the power of -1. Now that does not mean 1 over tan, that just means the inverse of tan. And the inverse of tan undoes the operations of tan and will allow us to cancel the tan in front of D, or the tan ratio. So that allows us to cancel here. Okay. And then we end up having D is equal to the inverse tan ratio of 7.4 over 6.5. And so D is equal to approximately 48.7 degrees. Now that I have angle D here, I can easily find angle F using this sum of the interior angles of a triangle, and angle F is equal to approximately 41.3. And you might be wondering why I'm writing approximately. It is approximate because the 48.7 is an approximate value as we approximated over here. Finally, what I'm going to do is I'm going to now solve for side E. And in order to solve for side E, what I'm going to use here is I'm going to use the cosine ratio for 48.7. So cosine 48.7 degrees is equal to adjacent over hypotenuse, so 6.5 over E. I need to get E by itself, so what I'm going to do is I'm going to multiply both sides by E. Okay, and then I'm going to divide both sides by cos 48.7. This will effectively allow me to isolate for E, which is then approximately equal to 9.8 meters.